multiply matrices. We shall do matrix multiplication. In part 3, we did the scalar multiplication. Here in part 4, we will do the matrix multiplication. And as we said in the previous video, matrix multiplication is where you multiply two matrices. That is, a matrix is multiplied by another matrix. So we have matrix multiplication. Here we see that a matrix is multiplied. A matrix is multiplied by another matrix. But, you know, due to the size of matrices, not all matrices could multiply themselves. But not all matrices can multiply. Okay? Not all matrices can be multiplied. By other matrices. A matrix is multiplied by another matrix. But in the multiplication of matrices, not all multiplication is feasible. We call this a conformability for multiplication. Before two matrices can be multiplied, they must be conformable for multiplication. Before two matrices can be multiplied, they must be conformable for multiplication. There must be conformability for multiplication. Now, what do I mean by conformability for multiplication? Say we have matrix A, A11, A12, A21, A22. And we have matrix B, B11, B12, B21, B22. So we look at the order. What is the order or size? What is size? This is what? 2 by 2. 2 by 2. The size of this is 2 by 2. Now, because the size, when we write the order, of course, this is the row by column. Row by column. Row by column. For us to have AB, okay, for AB to exist, for us to have AB, then the number of columns of A, must be equal to the number of rows of B. So take note of this. number of columns of A must be equal to number of rows of B. That's for AB to exist. And how do you take note of it? It's like this. So you see, number of columns of A is equal to the number of rows of B. It must be equal, must. Now, then another thing you need to note, the size of the product matrix, AB will be the number of rows of A by the number of columns of B. So the size will be this 2 by 2. The size of AB will be 2 by 2. Now this is very, very important. Number of rows of A must be equal to number of columns of B. That is, when they do that, then AB will exist. Now, the same thing, assuming we have BA. For BA to exist, BA to be feasible, right? In this case, if it's BA, then it will be B11, B12, B21, B22. And then A will be A11, A12, A21, A22. So for BA to be feasible, the number of columns of B will be equal to number of rows of A. You see? After writing this, you write the order or the size. In all the matrix multiplication we shall do, we will write out the matrix. The next thing is to write the size. It's very important. Then you check whether they are conformable for multiplication. If they are conformable for multiplication, then you multiply it. Right? But if they are not, then you cannot multiply. You cannot. The size there is 2 by 2, and the size there is 2 by 2. So, because the number of columns of B is equal to number of rows of A, then because of that, BA is conformable for multiplication. It's feasible. B and A, matrices B and matrices A, they are conformable for multiplication. And BA is feasible. Now, what is the size of BA? Size of BA will now be these two remaining here by these two. That is the number of rows of B by number of columns of A. That is what you need to know. That's the first thing you need to know. First of all, when you're asked about doing matrix multiplication, you check the two matrices first, whether they are conformable for multiplication. And how do you know whether they are conformable for multiplication? Check the size of the first matrix and check the size of the second matrix. If the number of columns of the first matrix is equal to the number of rows of the second matrix, then you can breathe out, which means they are conformable for multiplication. Then, what will be the size of the product of the two matrices? The size will be the number of rows of the first matrix by the number of columns of the second matrix. It's very important you know that. Now, let's go ahead and do, assuming they are now conformable for multiplication. How do we do the multiplication process? How do we do the multiplication process? That's the next thing we'll look at. How assume the two matrices are conformable for multiplication. How do we do the multiplication process? How do we do the multiplication process? This is very important. So we go ahead and write, as usual, A11, A12, A21, A22. It's good to write it out by the sides, okay? Matrix B, B11, B12, B21, B22. Now, of course, it's better to write the size always. This is 2 by 2. This is 2 by 2. And we see that these two, this is conformable. Now, how do we do the multiplication AB? AB will now be row by column. You take first row of the first matrix. This is the first matrix. The first matrix is A. First matrix is A. Second matrix is B. So you take first row of the first matrix and multiply by the first row of the second matrix. And after that, you take the first row of the first matrix and multiply by the second column. So first row of the first matrix times the first column of the second matrix, then first row, that gives you the first row of the product. Then the first row of the first matrix times the second column of the second matrix gives you the the element in the first row and second column of the product. Then after that, you take second row of the first matrix times the first column of this second matrix. Second row of the first matrix times the first row of the second matrix gives you this element here. And then second row of the first matrix times the second column of the second matrix gives you the element in the second row and second column of the product. So this is the way it works. A11 times B11 plus A12 times B21. You see? A11 times B11 plus A12 times B21. Row by column. It should always, when you're multiplying, it should always be row by column. Row by column. So this is the first element here. And this will be here. A11 times B12 plus A12 times B22. Right? Then here will be A21 times B11 plus A22 times B21. Then this will be A21 times B12 plus A22 times B22. Row by column, every time, row by column. And how do you check whether you're multiplying right? Look at these ends here. B11 here, B11, B21, B21. Because when you're doing it with numbers, it should always rhyme with the same number. If it does not, you're in trouble. Okay? B12, B12, B22, B22. It should always rhyme. Remember, it's row by column, and it should always rhyme. Let's go ahead and do BA. If I have to do BA, I don't want to come and start doing it with my head. I want to write it properly. Always write it in the way that you multiply it. I will first of all write B, B11, B21, B12, B22. And then A by row, A11, A12, A21, A22. So because I want to find BA, I will write B first. I'll write B first. Now, please, before you write BA, of course, the next thing is to write the size. This is 2 by 2. This is 2 by 2. It's always important you write this. And then because this is equal to this, because the number of columns of B is equal to the number of rows of A, then BA is conformable. And you see in this one, AB, we see that the size of AB will still be 2 by 2. All right, let's go ahead and do BA. BA will be row by column, watch out. First row of B times first column of A. So this will be B11 times A11 plus B12 times A21. You breathe in, or you breathe out. You know, you are breathing it, you write it, you breathe out. Then you breathe again, you know. The next one will be what? First row times second column. B11 times A11, A12 I mean, B11 times A12 plus B11 times A12 plus B12 times A22. And then you breathe out. You've ended it here. Then, next one, second row times first column. B21 times A11 plus B22 times A21. Then you do again. Second row times second column. B21 times A12 plus B22 times A22. Okay? Now if you look at this will still be 2 by 2 matrix. But how do you check whether you're multiplying right? As you begin to multiply, you check the ends, they must be the same. These ends, they must be the same. A12 here, A12 here, A22 here, A22 here. So they will be the same. And the size of the product will be the number of rows of B times the number of columns of A. With that, you won't have issues with this at all. You will not. Remember, the multiplication process is row by column. First row times first column, first row times second column, second row times first column, second row times second column for 2 by 2 matrix. You must not always get a 2 by 2 matrix, so know that. I have question 1. Find A times B and B times A, if possible. You have A to be 1, -1, 2, 6. B to be 4, -3 by column, -2, -2. All right. What do we write first? We write their order or the size. This is a 2 by 2. And this is 2 by 2. So we are good. Because number of columns of A is equal to number of columns. I'm sorry. Number of columns of A is equal to number of rows of B. So we are good. Now, the size AB will be 2 by 2. Number of rows of A times number of columns of B. AB will now be first row times first column. 1 times 4 plus -1 times -3. Then first row times second column. 1 times -2 plus -1 times -2. Then you close. Second row times first column. 2 times 4 plus 6 times -3. Second row times second column. 2 times -2 plus 6 times -2. How do you know you're getting it, the multiplication right? You see 4 here, you see 4 here, -3, -3, -2 here, -2 here, -2 here, -2 here. At least that gives you kind of a direction that you're going, that you're getting it right. So this will now be equal to 4 plus -1 times -3 is 3, 4 plus 3. Then here, 2 times 4 is 8. 8 plus what? -18. Then this is -2 plus -1 times -2 is 2. Then 2 times -2 is -4 plus 6 times -2 is -12. So this will now be equal to 7, 0. This is 8 plus minus 18 is 8 minus 18, which is -10. And then -4 plus minus 12 is -4 minus 12, which is -16. And this becomes your answer. That's it. Now let's go ahead and do B times A. For B times A, I don't want to come and start, I want to write B first. Now as you can see, this is 2 by 2. As you can see, 2 by 2. Now, for B times A, I don't want to come and start doing it because it's first row of B times first column of A. But I want to write it so that B comes first. I have to do that. 4, -3, -2, -2. I can do it any way I want. I can go ahead and multiply that. But for the purpose of my audience and for teaching you, I would recommend that you write, if you want to find B times A, you do that first. Okay, you do that first. And then this is A, is 1, 2, -1, 6. All right. So B times A, which is BA, will be row by column. I didn't put the order. Don't mind me. 2 by 2 here, 2 by 2. It's always good to do that. Always. Always good to do that. Put the order. Always. For the size. So this will be row by column, 4 times 1 plus -2 times 2. First row times first column. Then 4 times -1 plus -2 times 6. -3 times 1 plus -2 times 2. Then -3 times -1 plus -2 times 6. You check it, 1, 1, 2, 2, -1, -1, 6, 6. It rhymes. It should rhyme at the end. So this will be 4 plus -4, -4 plus -12, -3 plus -4, then 3 plus -12. And this will be 4 plus -4 is 0, 4 minus 4 is 0, -4 plus -12 is -16, -4 minus 12 is -16, -3 plus -4 is -3 minus 4, which is -7, 3 plus -12 is 3 minus 12, which is -9. Now, and it's still, the order is still 2 by 2. All right. Later on, we can talk about these properties of matrices. But as you can notice, here, you see that AB is not equal to BA. Can you notice that? AB is not equal to BA for matrices. Meanwhile, if you come to numbers, to real numbers, 2 times 3 is equal to 3 times 2. 2 times negative 3 is equal to negative 3 times 2. Negative 2 times negative 3 is equal to negative 3 times negative 2, which gives you 6. But for matrices, it won't work. AB is not equal to BA. So that tells you something, that the multiplication of matrices is not commutative. You know, with real numbers, multiplication of real numbers is commutative. It has a commutative property. Right? But multiplication of matrices is not commutative. All right, let's do another question. Let's do more questions. More questions on this. Question 2. If we have C and D, C and D, and then D and C, if possible. C is by row 2, 3, negative 1, 0, 4, 6. And then D is 2, 4, 1. All right, we're asked to multiply this. So what is the size? What's the size of this? This is what? 2 by 3, right? And this is what? 3 by 1. 2 by 3 and 3 by 1. So because the number of columns of C is equal to the number of rows of D, C times CD is feasible. C and D are conformable for multiplication, right? Yeah, CD is feasible. And what will be the size of CD? 2 by 1. It's going to give us 2 by 1. So one thing I like about matrix multiplication is it gives you an idea of the size of the product. So if you're not multiplying right, you see the check at the end must rhyme, the ends that I told you must rhyme, and then it gives you the idea of the size of the product you will have. So if you don't get the size of that product, then your multiplication is wrong. It's incorrect, okay? Now, let's go ahead and find CD. CD will be row by column, row by column. 2 times 2 plus 3 times 4 plus negative 1 times 1. And that's the only one we can have, because our distance will be 2 rows and 1 column, 2 by 1. Then the next one will be 0 times 2 plus 4 times 4 plus 6 times 1. As you can see, it rhymes at the end, 2, 2, 4, 4, 1, 1. It rhymes. That's one check that you have to do. And then the second check is to make sure that it satisfies the size of the product, CD, will be the number of rows of C times the number of columns of T. So this is going to give us what? What will this give us? This will give us 2 times 2 is 4 plus 12 plus negative 1. 4 plus 12 plus negative 1. And then this will be 0 plus 16 plus 6. And this will be equal to 4 plus 12 is what? 16. 16 plus minus 1. 16 minus 1 is 15. Right? And then 16 plus 6 is what? 22. So, and you see here that the size of this is 2 by 1. 2 by 1. That's it. Row by column, row by column. Now, let's look at DC. And what did I teach you about DC? What did I teach you? about this C, that you should do what? Write D first. So D is 2, 4, 1, and C is 2, 3, negative 1, 0, 4, 6. The size here is what? 3 by 1, and the size here is what? 2 by 3. So you see, 1 is not equal to 2. 1, the number of columns of D is not equal to the number of rows of C. Question 3. Find E times F and F times E if possible. So we have a matrix E. Matrix E is a 3 by 3 matrix, and the matrix F is a 3 by 3 matrix as well. So the matrix FE, E times EF, E times F, which is EF, because let's see whether this exists, okay? So this is a 3 by 3 matrix, and this is a 3 by 3 matrix. Because the number of columns of E is equal to the number of rows of F, therefore matrix EF exists. EF exists. Is feasible. So what would be the size of matrix EF? What would be the size? It would be the number of rows of E by the number of columns of F. So it will be a 3 by 3 matrix. Now let's go ahead and do the multiplication. So EF will be the matrix of, as usual, we do row by column, okay? We will do the first row of E times the first column of F, and that gives us 1 times 5 plus negative 2 times negative 5 plus 0 times negative 4. We break. Then we do first row of E times second column of F, and that will give 1 times negative 1 plus negative 2 times 2 plus 0 times 1. We break. Then we do the first row of E times the third column of F, and that would be 1 times negative 4 plus negative 2 times 2 plus 0 times negative 3. And then we close this. So then after that we now start with the second row of E. We use the second row of E, multiply the first column of F, second row of E, multiply the second column of F, second row of E, multiply the third column of F. And then we continue with the last row, which is the third row of E. So this will be 2 times 5. We are doing the second row. 2 times 5 plus negative 1 times negative 5 plus 1 times negative 4. We break. We continue. 2 times negative 1 plus negative 1 times 2 plus 1 times 1. We break. We continue. 2 times negative 4 plus negative 1 times 2 plus 1 times 2 times negative 4 plus negative 1 times 2 plus 1 times negative 3. We close. Okay? 2 times negative 4 plus negative 1 times 2 plus 1 times negative 3. We close. Then we do the third row. Negative 1 times 5 plus negative 2 times negative 5 plus negative 3 times negative 4. We break. We continue. Negative 1 times negative 1 plus negative 2 times 2 plus negative 3 times 1. We break. We continue. Negative 1 times negative 4 plus negative 2 times 2 plus negative 3 times negative 3. We close. So we kind of want to do a check like we said earlier. 5, 5, 5, negative 5, negative 5, negative 5, negative 4, negative 4, negative 4. Okay, negative 1, negative 1, negative 1, 2, 2, 2, and this is 1, 1, 1. Then negative 4, negative 4, negative 4, negative 2, 2, 2, and then negative 3, negative 3, negative 3. So we want to do that check. So this will now be 1 times 5 is 5 plus negative 2 times negative 5 is 10 plus 0 times negative 4 is 0. 1 times negative 1 is negative 1 plus negative 2 times 2 is negative 4. Okay. Plus 0 times 1 is 0. Then 1 times negative 4 is negative 4 plus negative 2 times 2 is negative 4 plus 0 times negative 3 is 0 plus 0. Alright. Then we have 2 times 5 is 10 plus negative 1 times negative 5 is 5 plus 1 times negative 4 is negative 4. 2 times negative 1 is negative 2 plus negative 1 times 2 is negative 2 plus 1 times 1 is 1. 2 times negative 4 is negative 8 plus negative 1 times 2 is negative 2 plus 1 times negative 3 is negative 3. Then negative 1 times 5 is negative 5 plus negative 2 times negative 5 is 10 plus negative 3 times negative 4 is 12. Negative 1 times negative 1 is 1 plus negative 2 times 2 is negative 4 plus negative 3 times 1 is negative 3. Then negative 1 times negative 4 is 4 plus negative 2 times 2 is negative 4 plus negative 3 times negative 3 is 9. Okay, so this is going to be what now? 5 plus 10 is 15 plus 0 is 15. Negative 1 minus 4 is negative 5 plus 0 negative 5. Negative 4 minus 4 is negative 8 plus 0 negative 8. 10 plus 5 is 15 minus 4 is 11. Negative 2 is negative 4 plus 1 is negative 3. Negative 8 minus 2 is minus 10 minus 3 is minus 13. You owe 8, you owe 2, that means you owe 10, then you owe 3, you owe 13. Negative 5 plus 10 is 5, plus 12 is 17. 1 minus 4 is minus 3 is minus 6. Please, I have said it earlier on, whether I say negative or minus, it means the same thing, okay? If you view my videos on integer operations, you will also see that, okay? 4 minus 4 is 0 plus 9. So this is your EF, okay? 5, negative 5, negative 4, negative 1, 2, 1, negative 4, 2, negative 3. And my E was 1, 2, negative 1 by column, negative 2, negative 1, negative 2, 0, 1, negative 3. All right. What's the signs here? This is 3 by 3, 3 by 3. 3 here is equal to 3 here. FE exists. FE is feasible, exists. And what will be the order? 3 by 3. Yeah, just like you have the order here, 3 by 3 for EF. Okay? Now, FE will now be what? F times E will be, which is FE, will be row by column. 5 times 1 plus negative 1 times 2 plus negative 4 times negative 1. Reading. Plus negative 1 times 2 plus negative 4 times negative 1. Then 5 times negative 2 plus negative 1 times negative 1 plus negative 4 times negative 2. Okay? Then 5 times 0 plus negative 1 times 1 plus negative 4 times negative 3. The next one is negative 5 times 1 plus 2 times 2 plus 2 times negative 1. Then negative 5 times negative 2 plus 2 times negative 1 plus 2 times negative 2. Negative 5 times 0 plus 2 times 1 plus 2 times negative 3. Then you have negative 4 times 1 plus 1 times 2 plus negative 3 times negative 1. Negative 4 times negative 2 plus 1 times negative 1 plus negative 3 times negative 2. Then negative 4 times 0 plus 1 times 1 plus negative 3 times negative 3. Okay, folks, what would this give us now? This will be 5 plus negative 2 plus 4. Then this will be 5 times negative 2 is negative 10. Then plus 1 plus 8. You just have to be careful, you know. How about these negatives? You have to be careful. Then this is 0 plus negative 1 plus 12. Then this is negative 5 plus 10. 2 times 2 is 4. Don't mind me. 2 times 2 is 4. Then plus negative 2 plus negative 2. Then 10 here plus negative 2 plus negative 4. Then here is 0 plus 2 plus negative 6. Here is negative 4 plus 2 plus 3. Then this one will be 8 plus negative 1 plus 6. 8 plus negative 1 plus 6. Making sure. Yes. Then this will be 0 plus 1 plus 9. 5 minus 2 plus 4. Yeah. Okay. And you know, you can do it mentally also. You can do that, but you just have to be careful. 5 minus 2 is 3 plus 4, 7. Negative 10 plus 1 is negative 9 plus 8 is negative 1. 0 minus 1 is minus 1 plus 12, 11. Negative 5 plus 4 is negative 1 minus 2, negative 3. 10 minus 2 is 8 minus 4, 4. 0 plus 2, 2 minus 6 minus 4. Negative 4 plus 2 is negative 2 plus 3, 1. 8 minus 1 is 7 plus 6, 13. 1 plus 9 is 10. Okay? Question 4, find E and F, G, let's use G, times H and H times G, if possible. G11, G12, G13, G14. Okay, but G is what? 2, -1, 1, 4, 3, -3, 1, -5, and H is -2, 1, -4, 5, 3, -2, -1, 1, -3, 2, 1, -1. All right, so let's find it. What's the size here? 1, 2, 3, 4. 4 by 2. This is 4 by 2. What's the size here? 1, 2, 3. 3 by 1, 2, 3. 3 by 4. Woo! It's not going to work. GH won't work. Because 2 is not equal to 3. 2 is not equal to 3. So GH does not exist. D and E does not exist. Does not exist. All right, now let's find H and G. Let's do HG and see what we got. H is, now H will be 3 by 4, another one will be 4 by 2, so it will work. It's gonna work. Excuse me, it's gonna work. H is -2, 1, -4, 5 by row. Then 3, -2, -1, 1. -3, 2, 1, -1. H, and then G will be 2, -1, 1, 4, 3, -3, 1, -5. So what's the size of this? This is 3 by 4, and this is 4 by 2. So this will work. Right? So because 4 is equal to 4, we say that HG is feasible. Yeah. H and G are conformable for multiplication. Because the number of columns of H is equal to the number of rows of G. And what will be the size of HG? Size of HG. Size of HG will be 3 by 2. We're going to get 3 by 2. So it tells us already what we're going to get. We have to get a product matrix that has 3 rows and 2 columns. That's all we'll do. Okay, folks, let's get this done. This will be row by column, right? Row by column. -2 times 2 plus 1 times 1 plus -4 times 3 plus 5 times 1. Right? Then you have -2 times -1 plus 1 times 4 plus -4 times -3 plus 5 times -5. Okay? It's going to be 3 by 2, 3 rows and 2 columns. Here will be 3 times 2 plus -2 times 1 plus -1 times 3 plus 1 times 1. Then this will be 3 times -1 plus -2 times 4 plus -1 times -3 plus 1 times -5. Okay, just making sure I don't make mistakes. Just making sure I do not make mistakes. All right? Everybody makes mistakes, you know. We just have to live by the grace of God. Now this is -3 times 2 plus 2 times 1 plus 1 times 3 plus -1 times 1. And this will be -3 times -1 plus 2 times 4 plus 1 times -3 plus -1 times -5. Right, 2, 2, 2, 1, 1, 1, 3, 3, 3, 1, 1, 1. -1, -1, -1, 4, 4, 4, -3, -3, -3, -5, -5, -5. Right? Okay. So we go ahead and get this done. Let's get it finished, not started. We have to get it finished. Let's get it finished. Now, this is Hg is equal to -4, you have to be careful here, plus 1, plus -12, plus 5. Then this will be 2, plus 4, plus 12, plus -25. Then this one will be 6, plus -2, plus -3, plus 1. And this one will be -3, plus -8, plus 3, plus -5. Right? Then this is -6, plus 2, plus 3, plus -1. And this is 3, plus 8, plus -3, plus 5. All right, so this will be, we probably need to, it's a lot of numbers, so let's just go ahead and see what we can do. -4 plus 1, -4 plus 1 is what? -3. So -3 minus 12 plus 5. You can just do it the way you like. This is 6 plus 12, 18. 6 plus 2 plus 4, 6 plus 12, 18 minus 25. This is 6 minus 2. 6 minus 2 minus 3 plus 1. This is minus 3 minus 8 plus 3 minus 5. I can do it mental work, but I would encourage you, when you have a lot of numbers, try to simplify your work. Try to make it easier for you so that you don't make mistakes. Then this is a -4 plus 3 minus 1. And this is a 11 minus 3 plus 5. So we got it now. This will be what? -15 plus 5 is what? -10. 18 minus 25 is what? -7. Right? See that? -7. 6 minus 2 is 4. 4 minus 3 is 1. 1 plus 1 is 2. Minus 3 minus 8 is minus 11. Plus 3 is minus 8. Minus 5 is minus 13. Right? Minus 4 plus 3 is minus 1. Minus 1 minus 1 is minus 2. Right? 11 minus 3 is 8. Plus 5, 13. And what is the other 3 by 2? 3 by 2. Other size of the Hg. Okay. We shall stop here for tonight. If you have any questions,